Go.
Go. Hello. Hi, everybody. Welcome to another episode of Continuous Discussions, the online forum where we talk about Agile, DevOps, and continuous delivery. I'm Sam Fell.
And I'm Anders Wahlgren, and today we're talking DevOps for big data, machine learning, artificial intelligence, business intelligence, real-time stream processing, big, huge data applications. Well, they're all around us, and data is only going to grow. I don't know of any databases around me that ever shrink. So this is only going to get bigger and more interesting, and along with the commoditization of data and business insights as well. So today we're going to talk about how do DevOps and big data interact. What are some of the unique challenges for practicing DevOps for big data applications? And as always, some best practices and good patterns for combining, deploying, and maintaining data analysis algorithms and backends. And as always, we've got an awesome panel. Sam will now talk to them and introduce them.
Wonderful. Thank you, Anders. Adrian was not able to join us today, unfortunately, but let's start with Andy Mann. Andy, welcome back to the program.
Hey, Sam, how you doing? Nice to be here.
Thank you. I'm happy to be here as well. All right. JD, welcome to the program. Fresh face.
Yeah, thank you very much for having me. It's a pleasure to join.
Wonderful. And Pete, good to see you again as well.
Yeah, thanks, Sam. Good to be on the show again. I'm a solutions architect from Cloud BI, specializing in data warehouses in the cloud. It's great to be on the show again. Thanks.
Perfect. That's a perfect topic for you to be aware of and be smart about, because that's what we're talking about is big data on C9D9 today. If you want to talk about big data, but you are not a panelist, and you'd know if you were a panelist because you would have just introduced yourself to hundreds of thousands of people live on YouTube right now. Join us on Twitter. You can use the hashtag C9D9 and follow along. Let's go ahead and let's get started with our first topic, why DevOps for big data? So why would you want to use DevOps practices and patterns when you're doing big data applications? And let's start with Pete.
Thanks, Sam. So a few points on this one. First, I'd say is it enables teams to work on big data projects rather than individuals. So you have a danger when you're doing big data projects that you can have individuals working on those projects. They can get deep into the details themselves. They can do all sorts of great work, but then other people might not know what's going on, which is a problem for the analysis phases of these things. Sometimes it's just analysis, but it's an even bigger problem when you want to productionize what's going on there. So if you're using DevOps techniques of automation, checking in what's being done so everyone can see what's going on, deploying that stuff automatically, running it automatically, then it's much easier for teams to take ownership of the work that's actually being created rather than individuals. That's a big benefit of using DevOps for big data. An example of that is that quite often you can have huge benefits coming from big data work by small teams with tiny budgets, is one way to put it, perhaps. If you're trying to have a small number of people deliver really large amounts of benefit, but with really small, tight budgets, then the kinds of controls that you have with DevOps techniques allow you to do things like set up your pipelines, test them really cheaply on small amounts of data, and then deploy that stuff to a massive cluster that costs quite a lot of money, process that stuff through, get the results that you really need, not have to worry about, oh, did we actually do the third step the way that we said the fourth time that we changed it over? All the code was checked in. You can rely on what you've actually got there. Other things to do with big data and why DevOps is handy for that is you've got to have tight treatment of the sensitive data that you might have in big data solutions. And what makes data sensitive is the context of that data. With big data solutions, you have lots of disparate data, so people can correlate that and they can make it more sensitive by the very fact that it can be correlated that way. So using DevOps techniques of being able to audit everything that everybody did to that data, that's a big benefit there, specific to big data for DevOps specifically.
I think that's an excellent point, Pete. That it's not something that I had ever even thought of, but the whole idea of the regulatory and compliance aspect of and sort of the way that you can lock that down that's perfect for when you're trying to handle this sensitive data. I love it. Thanks.
Yeah, and that meshes too with the the State of DevOps report talking about how high performing DevOps teams spend a lot less time doing rework due to things like security problems. So if you're dealing with a huge batch of data which is sensitive in some ways, DevOps is going to help you keep that more secure than otherwise. So that meshes very well, I think.
Yeah, I love it. Absolutely. We find that the security people now that we work with on data warehouse projects, they really like DevOps stuff because you can show them exactly what you did and what will happen every time it's done, rather than having to audit individual instances of things happening. And they can also know that that will happen no matter what data goes into the system. So that's a big benefit there. Just a couple other points that I had on there. You've got quite a lot of management benefits of using DevOps techniques with data projects. So just like with agile development, if you're using good agile techniques, you're in a better position to know when the work is actually done. With your big data projects, a lot of knowing when the work is done is experienced in production because it's done when you've done it to particular data, rather than it being just, say, the calculations or the development work that you create. So you need good controls of what's going on in production to be able to manage knowing when you're actually done with the work happening in production. And so it's a big help in that sense as well. Documentation you essentially get for free if you've got good ways to audit, to browse the things, the rules that you've checked in, for instance, say your pipeline definitions for how you're processing things. And then there's all of the stuff to do with it's just more pleasant to work in a DevOps kind of a way. There's that book called Drive about what it is that gives people the best motivation to work on things. It talks about autonomy, mastery, and purpose as being the things which really drive people to do the best work. And if you're using DevOps techniques for your big data stuff, then you've got more autonomy because you've got access to the resources that you need to get stuff done. You can get a big enough cluster because people will just like authorize you to get the size that you need, and no more than that. That's great. You don't have to wait for someone to go and plug in servers. You've got the mastery side of things because you're limited by your skills, not by paperwork. And you've got purpose because you can actually see things through to actually working in production rather than doing just a small piece of the puzzle. So you've got like quite a significant motivational factor in terms of like getting teams to do more stuff, which I think is a great benefit of using DevOps and big data as well.
I love it. Wow, that's laying down some fantastic information right there. It's funny because a lot of those things, just DevOps in general, right? That these are all benefits of DevOps, and we just did a C9D9 a couple of weeks ago about hiring for DevOps and how being in a DevOps environment is just a much more pleasant, as you said, sort of way for folks to work, more iterative, more agile, all that good stuff. And applying all that to that domain of big data certainly makes a ton of sense. Yeah. So Pete, thank you so much.
Yeah, I think that the self-service aspects of DevOps are kind of interesting too. We have some experience working with pharma companies and their data sets. And one of the interesting things they had to tackle when they did kind of self-service standing up of environments with data along with it was, hey, with this piece of data, can we put it up into Amazon, or does it have to stay inside the firewall for IP or HIPAA privacy concerns or things like that? So the whole idea, the whole notion of self-service and those kinds of things, I think work really well in an environment where you've got sensitivity issues that you need to deal with. Prevent mistakes by funneling people down the right road depending on the data that they want to put out there.
Right. Yep. Absolutely. All right. Very good. Hey, JD, what are your thoughts on DevOps?
Yeah, so I come at it a little bit more from the developer background. I used to be a pretty active software developer, and we were sort of doing things like, continuous integration, continuous deployment and whatnot, probably about 10 or 12 years ago. And one of the things that I find interesting about it, the compliance stuff is really interesting. But from the developer standpoint, I look back at some of the challenges we used to have. Things like, the developers, you'd write your code, you'd be sitting there going, oh yeah, well, I it runs pretty quick. I've built this thing and it handles 10 gigs of data. you know, and then it goes into production. You're like, well, there's a petabyte of data, and it falls over. So I find sort of having the developers on the sort of cultural side, having a better understanding of the operational side and what's really going to happen in production, just really good for improving software quality. Secondly, is just the scale. You mentioned, you know, the databases don't get any smaller and everything's getting bigger, you know, and we have to automate. We absolutely have to automate. Long gone are the days of like, well, maybe I'll just copy and paste this backup through remote desktop. Like, you just, you know, if you're talking terabytes or petabytes of data, that's just not going to work. We have to,
because I've done that.
we all have, you know, those things are, to me, the interesting part of how do you amplify the capability of the individual engineer through DevOps practices and to better handle truly, I mean, there's two schools of thoughts as well, right? There's a lot of people who think big data is like, hey, I've got 1 terabyte of data. And then you've got the, hey, well, I've got a fleet of 50,000 servers that I'm automating. And, you know, it's always relative to the individual. A few terabytes might be big to that person, but immediately you're already having to start at looking at some of the automation play to make it actually work. So they're just a couple of things that I think are interesting about how big DevOps and big data sort of intersect together.
Yeah, I think another interesting thing that I've run into is through an acquaintance of mine who works in genomics. And, you know, one of the things they have to deal with there is you can't move the data around. It's too big. You have to bring the algorithm and the people and the viewing and the analysis to the data, because you can't move the data around. There's just too much of it, right? It has to kind of stay where it is, because it would take you a year to move it. So, you know, this notion that we want to move everything around. Oh, we'll just put it in a Docker container and we'll move the container through. And it's like, no, that doesn't really work. We can't bring the mountain to Muhammad. Muhammad has to come to the mountain. In this case, data. So
unless you've got the Amazon trucks, right? You've seen those trucks. It's crazy, but that's what people are doing with this data, and they have to do that to move the.
It's SneakerNet, only on a bigger scale, you know.
Exactly.
Well, you're also running into situations as well where I think everybody that's doing stuff with colossal volumes of data is benefiting immensely from the free ingress to the cloud providers, but you can't take it back out without spending an absolute fortune. So, yeah, that's another thing to keep in mind.
As the commercial said here in the States, roaches check in, but they don't check out.
Yeah, exactly. Awesome. All right, JD, that's very good. I appreciate that. Andy, as a guy who comes from a company you guys do quite a bit of stuff with big data, and you guys do a lot of stuff with DevOps. So tell me a little bit about your thoughts on DevOps and big data.
Yeah, absolutely. I think the thing that I see most often in using DevOps techniques around big data is that the culture of continual learning fits really well into the idea of examining data to figure out what you want to know. It goes back to that old Rumsfeld thing, you know, the known unknowns and the unknown unknown. I mean, big data is just one big pile of unknown unknowns. So the iterative cycle of being able to do inquiries, adjust a little bit, do it, adjust, you know, so iterating. But, you know, the DevOpsy part of this is very much because you need that collaboration between the developers who are creating these algorithms and trying to understand what's going on in the code, the business leaders and others who are trying to, you know, understand from a business perspective what they need to find out, but they don't know what the data says yet either. And then in operations, being able to run that efficiently, run fast queries and get responses back. You know, all of these teams working together collaboratively and iterating, asking new questions, because invariably when you use big data, and this is what we definitely find with our customers, they're using Splunk to query these big data sets. You don't know what you're looking for until you find something that points you to what the next question should be. So it's continually asking these new questions. And that's so DevOps, right? The continual learning. So that's one area I certainly see from our customers, you know, the collaboration, working together with business, culture of continual learning. These things all really go together well when you're trying to interrogate DevOps data, big data sets.
Mm-hmm. The whole idea of pipelines, I'm surprised that nobody has sort of brought that up as another parallel, I guess, between DevOps and big data. You think about the way that you deploy applications through that pipeline, that value stream. Data has to go through a value stream also. I guess you could just sort of dump it into the big data swamp, but there's work that's done as that data is ingested to make sure that it's fit for use by whatever data scientist or whatever purpose you'd like to apply to it. And so any thoughts, Andy, on that, on how people work that data ingestion, or the DevOps way? You talked about that collaboration and making sure that these folks are working together. You can't have someone that slices off the most interesting parts of the data up front and expect to be able to get those answers on the back end. So how does, thoughts on that, anybody?
I'll just jump in quickly. I don't know a lot about that because I'll be honest, we don't, the way we ingest data, we don't need to sort of manipulate it and put a schema on it or anything like that. You just sort of ask it and then you keep working on it. A lot of big data repositories are, in fact, there's that big data lake. And so you do need to be able to work with very diverse data sets. But yeah, I mean, I'll turn it over to other people who might know more about applying schemas and stuff like that.
Well, with a data warehouse bias on this kind of thing, we're always looking to what do we have to do to that source data to get it into, say, Redshift or whatever we're using, and the rules that we go by are basically, you don't know what data you're going to get, you don't know if you're going to get all the data you expect, and it might be wrong. So you're better off. It's better off expecting it to show up in the wrong order and have bits missing. And with the kind of old-fashioned way of developing the ETL process, so the pipeline of getting the data in for processing, if you have to manually set all of that stuff up on production, then it's very difficult to then go and put all of that stuff in a test system so that you can then feed it with data that shows how it will behave when bad things happen, especially if you're like in a hurry to make a brand new ingest process. But if your whole pipeline process can just be deployed to a test environment as easily as possible, and you've got test systems which allow you to then easily mock up bad data and then check that the system behaves the way that you're expecting with that mock data, then, well, that's great. I mean, you can even define those tests before the developers get going with it and say, look, it's got to handle all of these bad scenarios because the people sending us this data really are that bad. Another aspect of it is actually on the producer side, to the people who are actually sending you the data. I mean, you might be dealing with a supplier of data who's got like a great process for defining a feed itself. So they will always send you a CSV with 200 fields and it'll always be exactly right, but there may be some manual process hidden in there. Like, for example, they may have the date scoping of some batch extract thing that they send you like every hour or something like that. Might be some manual processes involved in setting what the date scope of things are. And so it could be like every so often they just like forget to send you the history of the data that they're supposed to be sending you. So, I mean, we kind of added to our rules of thumb for dealing with source systems, and that is to say you need to decide how many nines of reliability you want, and if you've got any manual processes in there, you'll probably get 1 9. You can have maybe you can't have 2 9s if you've got manual processes on that are to do with the data that's being sent to you. You might be able to get 11 8s of reliability or something like that, but you're not going to do better than 1 9.
1 9, so 9%.
Yeah, well, yeah,
all right.
We've had weeks worse than that, actually. One of the things that's been great with using AWS for we use data pipeline for the for controlling our Spark processes, which do the ingest into Redshift for a kind of standard way of processing data in, and it's been great how easily we can just deploy that and then test it for different types of things that go wrong with the data. Because those suppliers of data, some of them are good, some of them are really like more terrible than you really would have expected was possible. But with DevOps, you've got the tools to test for the worst expectations that you could possibly have, and then do the best you can with that.
That's wonderful. Awesome. All right. So great conversation so far. I'm learning a bunch already. Let's shift gears and talk about DevOps and big data, some of the challenges and some of the unique considerations that you need to, I think we may have touched on some of these already, but what are some of the unique considerations that you need to be aware of when you're doing big data with DevOps. And let's start with Andy this time.
Yeah, I mean, certainly the volume is for me, certainly with the way I work with my customers, we're talking petabytes of data, terabytes at least. Dealing, as Anna said, dealing with that level of data, and you have to do it in situ. So things like, we talk a lot in DevOps about data, test-driven development. We talk a lot about, data-driven decisions. And with the volume of data you're talking about, being able to test on it, and we touched on this before, testing on a small data set can give you radically different results. And so, we'll get on to machine learning a little bit later, but the idea is that to be able to deal with that volume of data, and this is where DevOps, I think, really helps, because you can work within incrementally increasing sizes of data sets and see if the results are right or not. Keep iterating on those results. I mean, so I would certainly call out the volume of data, your inability to move it around. Can't just do development on your laptop because you don't have a hard drive big enough. All of the tropes of agile development, well, not all of them, but many of them become a lot more difficult simply because of that data gravity around that huge data set. Certainly one part.
Absolutely. And so the idea of coming up also with realistic test data that if it's secure data, how do you make sure that whatever algorithms you're writing or whatever you're doing is going to work against, so something simple like a social security number, right? You need to be able to have an application or whatever your big data application is, look at this pool of numbers, understand that it's a social security number, but then somehow obfuscate some of if you're testing, you don't want actual social security numbers in there. So you have to obfuscate those numbers and swap them out with fake data. Preparing that data, that's also work to tokenize that stuff and get rid of, make sure that if it's alphanumeric, that there's an alphanumeric in there so that when you're testing your code, it's going to be the same in production as it's going to be in test land. That's a tremendous amount of work for people, especially with that variety. You talk about volume, but the variety of data too. What else are you sucking in that?
I mean, just on the variety topic as well. I mean, I think there's actually partially a misnomer there, because when you think about data variety, you think that that's difficult. But if you're getting sensor data out of industrial equipment, which is throwing off, thousands and thousands of metrics every millisecond, you think about these giant turbines that are sitting in power generation stations, for example, and the slightest millimeter variance will throw that whole system out. It'll send blades spinning out into the container. Not the Docker container, the physical container. And that's actually a real problem for volume and variety, because typically the variety will be minimal, because the same thing is happening every millisecond. Your challenge as a developer is to be able to predict the thing that will go wrong. So that little spike that happens, that one data point in this whole lake of data. So finding variety in the volume can actually be challenging, because if you've only got a small test data set, you may have no anomalies in it at all. How do you develop an algorithm to find an anomaly in a data set that has none? So these sorts of problems all of a sudden pop up, which would not exist in any other kind of data processing.
That emergent telltale sign doesn't emerge unless you have just a ton of data. That is very interesting. That's an interesting point. Absolutely. Anything else, or should I move on?
No, move on.
All right, let's move on. You can always come back to that later. So, hey, JD, what are your thoughts on this? What are some of the unique challenges and considerations when you're doing big data and DevOps?
Yeah, well, I think obviously the volume of data is a challenge, but touching a little bit there on the analysis of the data, we talked a little bit earlier about smaller teams, being able to achieve more and whatnot with automation. One of the things I constantly think back to is, gosh, I wish I'd spent more time paying attention in statistics. Like, there's actually some math I would have used. And so considering as Andy was saying there, if you've got a smaller team, you don't necessarily have, say, a dedicated data scientist. as an example, how do you sit down and start building some of these models where you want to actually say, well, I need to detect an anomaly, and maybe the developer doesn't go, hey, it's a 1 millimeter change in the blade scenario, but they kind of just go, well, I'm going to write a test where it moves by 1 kilometer, and it's not really real, but hey, it demonstrates a failed test, if you will. Mm-hmm. Things like that I find are sort of interesting as well. And I say that we have people that do deal with the data science side, but not everybody is sort of wired that way. So just in terms of talent on the team, that can sometimes be an issue with dealing with that. Lastly, I would say, and this comes from talking with other businesses out there, is because you can't do it all on your laptop, is ensuring that the team is empowered to actually run up various servers on Azure or AWS to be able to leverage that data and use the real data in a way that they can properly test. And I've seen some organizations which lock that down, so they can't. And usually it's locked down because I know of some companies where they discover they're spending $800,000 a month extra on servers because they never shut them down after testing. And I know there's tools and providers around that these days as well, but you've got to basically allow the engineers to operate at cloud scale, if you want to call it that, to really test this stuff.
That's to Andy's point, exactly. If you're not actually doing it, then you're not actually doing it.
No.
Anders always talks about, hey, you know what? We all sort of test our code in production, right?
Well, yeah. I mean, I didn't put it in the introduction, but at Raygun we do software crash reporting and real user monitoring across like 20 different programming languages and environments. And our big pitch is, whether you want to admit it or not, you need to know what's happening in production, because even with a QA team, we've all sat there and had software not work for us. You need that safety net.
Production is the most production-like environment you'll ever test it in.
Absolutely. And it's also the highest cost failure, right? You piss off your customer, and we only get to do what we do because we have customers. So
that's right. You can only piss them off if you have them. So get a lot of them, and then don't piss them off, is I guess the
exactly.
Right way. Yeah. Excellent. All right. Thank you, JD. That's great. Pete, what are your thoughts on some of the challenges and use considerations?
Yeah, following from that point about testing on production, you can get a lot of benefit for not very much cost if you can have very tight control of what you're actually doing on production. When thinking about things like say a Redshift data warehouse, if you want to try like small changes to how a transform works, in terms of the logic's the same, but the way the queries are structured are a bit different, then you can essentially test that without having to pay for another test environment. If you've got tight enough control that you know that you can run that small variant on production and know that you're not going to like roll back some other change that somebody changed at 10 o'clock last night because they were fixing some bug that they didn't tell you about. So having those kind of DevOps controls on there allow you to get the most value out of your production environments in terms of doing those small tweaks that will increase the performance there. Another challenge, I suppose, of the of big data specifically is it's to know what you're optimizing for. So with AWS, they have the 5 pillars of their well-architected framework, and the 3 that you actually trade off are the cost effectiveness and the reliability and the performance efficiency. So with the big data solutions, they can be like really quite tightly linked. Like if you want to make sure that all of any batch processing that you've got running finishes in a certain amount of time, then you've also got to consider, well, if I have more performance, then I'll get there better. So there's a lot of specifics to the particular things that you're doing to look into there. But sometimes there can be some challenges around that stuff, and like generally being able to control the cost of your performance testing is a big thing that can actually help you solve that problem. And that just comes back to the previous point, really, on having tight controls of the few environments that you have, because it's easy to run up like big bills if you don't do that. I think another point is that we're like coming from a more traditional data warehousing background, where like years ago people would be like working on NetEaser and like deploying manually and saying things like, oh, I like to deploy the code manually using a SQL client so that I have control. And the thing I always think there is, if somebody says they like to deploy manually so they have control, they're depriving the team of control. You know, the person is taking control at the expense of the team having control, because the team doesn't know what that person is doing specifically. And another point I would come up with there is, if people are still making decisions when they're deploying, they haven't even finished development, let alone tested the thing that they're deploying.
I like that. If they're making decisions,
yeah,
we're going to steal that.
Not ready yet. You have to still think. I agree.
Yeah.
Yeah.
So, yeah, that was, yeah, I wanted to finish on that point then. Yeah. Okay.
I love that point. I think that's a fantastic place to finish. Very good. Okay. Anders, what are your thoughts on the challenge and considerations for big data and DevOps?
I was thinking a little bit on this notion of kind of, you know, iteration and agile and those kinds of things. I'm thinking back to, you know, high school and middle school, when we had to use this thing, which most of us probably know what it is, but it was called the index of periodicals. So you would go to the library and there would be bound books, which was just an index into, you know, Time magazine. And if you were looking for a particular subject, you'd flip to that word and it would list all the periodicals and what issues, you know, had that keyword in it, you know. So we've gone from a world where, you know, you had to in advance know all the questions that were going to be asked so that you could produce an index that would have the answers to those. And in general, I mean, when it comes to querying and those kinds of things, a lot of times the magic or the secret sauce is compute the answer before the question gets asked. That's how we do it fast in the past. Nowadays, it's a little bit different, because with massive distributed computing and machine learning and all of these things, you know, some of which we'll talk about going ahead, you actually can do these computations more in real time than in the past, when you had to kind of pre-compute all the answers. And you know, we went from those keywords in the index of periodicals to, you know, in the 90s, we now have fully inverted indices where you can search for any word because we've computed an index of every word that occurs in the source data, to, you know, that's not even enough, you know, nowadays, where we can't even have a single index that's large enough to contain all of that stuff. We need to farm it out to, you know, a cluster of 1 million machines or 100,000 machines to do it. So the scale of the data that we're operating at requires us to do this massive distributed computing in order to answer the questions more in real time, because we don't know the questions ahead of time as much as we used to. And that was always the magic, was know the question ahead of time so you could pre-compute the answer. That, you know, that's optimization.
Right. Yeah. When you can't optimize for the unknown.
Yeah.
It's very difficult to do.
Yeah, it's kind of pain. And you know, then, you know, when you started data warehousing, you know, you got into the scenario where you get a few iterations into it, and you realize that the kind of question that you're now wanting to ask requires you to go back and restructure the data or restructure the indices. I mean, in you know, with these huge data sets we're dealing with these days, that's prohibitive, right? That's a you know, go back to square one, you fail, you know, start over, kind of a thing. And so we've evolved, you know, to sort of figure out, you know, ways that we can index data and ways that we can access the data, where we have more flexibility in how we ask the questions, and don't rely as much on these pre-computed answers, because, you know, they're so expensive to pre-compute at the scale. So you know, the science kind of had to change around it.
Right. Excellent. All right. So that makes sense. We're going to move to our next topic, which is patterns for DevOps for big data. What do you see people doing? What are things that people should be doing? And people have touched on this already, the machine learning aspects and how that data is used. Feel free to jump in with that as well. I'm going to start with JD this time. JD, what are your thoughts and patterns for DevOps for big data?
Well, from the purely DevOps part, ignoring big data for a second, is obviously just getting that automation pipeline in. You know, getting code to be built and tested reliably and deployed in a consistent manner. You know, frankly, it seems like most people are there now, but if you're not doing that, that is like the lowest hanging fruit for just improving everybody's life. Secondly, and this is maybe a little bit specific to us, or maybe to other people as well. But we ended up where we had to build a range of different little internal tools for doing things. So we do deal with close to about a petabyte of data at the high end at our scale. But we found that we were having to build little tools to help do things like, hey, test the way that we do the alerting, test the way that we are doing grouping of data and things like that. This kind of goes back to your earlier comment about how do you handle the data changing. And again, specific to us, what we do is we sort of cold store all of the raw data, and then we do a various levels of transforms and storage into different data systems for how we want to do fast lookups, what parts need to be pre-computed and all of that. But the reason we store that sort of long-term archival raw stream is that if we decide we want to deliver a feature that requires us to fetch something out of that old data, we can reprocess that entire raw set. Secondly, it also acts as what I call our catastrophic failure, backup. We'll just re-ingest everything at our own cost. But so that's in there. And so we've had to build a range of tooling around that to help the developers work, again, from their own machines, automating some of the stuff into the cloud, hooking into some of those production systems in a way that does we are HIPAA compliant, for example, make sure that we're not bringing that data back into the office environment, being able to query it out of Azure, things like that. So in terms of patterns, yeah, start off with the basics, with the usual DevOps stuff. And secondly, we've just developed tooling around how do we empower our developers to make the most out of that if they aren't wizards with the cloud environments and stuff like that. That's just us, though.
Right. Yeah, you got to make it approachable for people. And safe. Right. I don't want to be afraid of pushing the button that you've told me is the magic button. So,
well, it's the same thing as like if you consider something like, say, Spark, which is an amazing, Swiss Army knife of tools. You can end up in a situation where if a developer or even an ops person isn't fully trained on that, they might do something that's destructive. And so, sort of gating that so that you can have more management around that is important. That's why we tend to put facades over things ourselves. Just to make sure, hey, don't delete the production data store. Yeah,
exactly. Awesome. Okay, thank you, JD. Andy, what are your thoughts?
Yeah, I think don't delete the production data store is some of the best advice I've heard all week.
And we've probably all done it.
Oh yeah, that's a whole new episode. I definitely think it's the core trope of DevOps around, one of the big patterns is around collaboration, obviously. So working together to find the questions. And this is, I can't say this enough, the idea of the data will suggest more questions. Every answer you get will probably pose more questions. So being able to work on, and this is where actually working in production may even be a pattern as opposed to an anti-pattern. Notwithstanding the ability to delete the entire production data store, a lot of big data activity is read-only. And so the data, to a large degree, depending on what you're looking for and what you're trying to do, you won't change it. If you can ask it all sorts of questions, as long as you don't have to re-schematize it, then you can certainly ask more questions and more questions. And so collaboration with someone who knows what they're asking. So as an IT person, I don't necessarily understand what I'm asking my turbines. I don't necessarily understand what I'm asking my retail data set. I don't necessarily understand what I'm asking my demographic data. But as someone in sales or marketing, someone in product, someone in engineering, like physical engineering, I know what I'm looking for, or at least I know when I see it. And so I think that collaborative mode, really getting together and working in small functional teams is really critical. I'll also touch very briefly on the idea of ML, machine learning, because of the data set so vast. It's going to be pretty much impossible for you as a human being to be able to see patterns, especially when a pattern is literally a blip on your radar. Could be literally on a radar, in actual fact. When you talk about military applications, for example, processing huge satellite data sets, trying to see something that maybe wasn't there yesterday, and finding that needle in the haystack. So very much about the iterative mode of processing and looking for those needles in the haystack. I think there are a couple of the big patterns that I see certainly amongst my customers who are working with maybe not massive military style or weather style, or some of them are working with energy data and that sort of things. People like the National Research Energy Laboratories, the NREL, doing amazing things, reading data in and doing those analytics and finding those patterns. So you've got to use machines that understand how to find those patterns. And that's something I think that is not normal in a lot of our endeavor, but is absolutely critical when it comes to big data.
Right. Yeah.
Just adding to Andy's point there, I think that's also encouraging because I think DevOps is as much culture as it is tooling and whatnot, is encouraging that mentality. I say a lot around the office, pull on the thread. You notice something, go digging, find out the why, and encourage that approach.
Absolutely. Being curious is one of the most important things. But that's why we're here as human beings, just because we were curious. It killed the cat, but it seemed to have done pretty good for humans. Although I'm sure there are a lot of dead humans because of curiosity as well. So my heart goes out to those people who aren't listening. So Pete Grant, what are your thoughts on this?
I think that's a great point Andy was making about a lot of the big data activity is read only. I think that I would add on to that as well, is that if you've got if you're trying to keep the costs as low as possible for your infrastructure, then it's not going to be sized so that there can be an infinite amount of users running whatever queries that they want onto that infrastructure. So just obviously, you would have sized the servers too big if that was happening. So what you can do though is you can use some DevOps techniques to figure out how much capacity you need to serve that that set of users or that expected amount of use of your data, and you can actually scale that up and down as needed as well. So the DevOps techniques help out a lot with being able to scale the capacity that you need for that side of things. In terms of things like processing pipelines and so on, a thing that I focus on a lot more now than I used to is really focusing on working out where the decisions are made and how those decisions get tested to find out whether they're correct when it comes to things that you do to actually do the development. A challenge that we quite often have with data warehouses is someone can't work out how to do a deployment completely hands-off. They say, I need to be involved in this while it's happening. And I think that the problem can quite often be to do with the choice of approach. As much as it is the ability to actually implement a certain type of automation. And so by being really conscious of where the decisions are being made and how those things are tested can help solve that. So a really specific pattern that one of the Teradata developers that I work with came up with. Hi Keith, if you're watching this, I'll send you the link. He came up with this great concept that with deployments on a data warehouse, you quite often have processes to create the daily batch. And so you'll go and test, does it process the daily batch or the hourly batch or whatever it is. But you also have a almost separate activity to go and to prepare all of the history data. So you might be doing 6 years of extract of data, preparing it to go into the same format as the daily batch data. But that's a one-off activity. And so all of the decisions around whether that stuff is correct don't actually need to be repeated. So what you can do is when you come to your production deployment, you can say, well, we've got this window to go and deploy this stuff. We can go and prepare all of that history data separately from that, that critical path sequence of events to get the production batch, the new batch processing stuff deployed, and we'll test it in our own time, and then we'll have this block of data that we can just put into place as part of the automation. But the preparation of that history, people can make their decisions as they go and then prove that it's correct at the end because it's not going to change. So I think techniques on that stuff, it's specific to the particular domains that you're working on and things like that. But I think working out what those techniques are based on where the decisions are made can be super helpful. I'd say regarding reporting systems, you quite often don't need PII data in there. And so if you can find a way to not need PII data in your production version of the reporting system, it will mean that you don't need to then go and mask the production copy of the data when you're doing the testing. So I quite often data warehouses I worked on, the production data didn't have any PII in anyway, because it makes it less of a target. But then, if you get the choice of thinking one way or another, yeah, better off just not having it. Really, it'll make your testing easier as well as not being a target. We get a lot of benefit out of using AWS Spot instances. Brings the cost right down. It's super easy to use if you've got DevOps controls around. You know what you're going to use, what you're going to bid for those Spot instances, and things like that. Data lakes. If you've got lots of objects and you want to run like Spark over that or whatever it is, then if you put your data on S3, you've got versioning built into that, which makes it like super resilient and easy to work with. And also, if you're putting if you're putting temporary clusters running on top of that, you can scale up and down the capacity as you need, and don't have to think about backups separately from that. There's a bunch of techniques that we've used to do with like interacting with customers who want to specify something in the form of a spreadsheet, some rules or something that they want the data to look like. They want to say, chop off the first 3 characters of this and put it in that field and all that kind of thing. Like in the old days, they would give you a Word document with a whole load of rules, and then some guy would type it in, and then you'd have some tests to say, does the Word document match what the guy typed in and stuff like that. We've had quite a bunch of success with having people write that stuff into Google Docs, have a Python script go and read the Google Docs and turn it into a YAML file that the rest of the infrastructure can then understand and uses the transform rules, and we can then push through a whole bunch of automated tests. So what we're doing is with the way into the specification process is someone creates a Google Docs, but we check it as part of the pipeline, so that we can understand what's in the Google Docs sheet. When we check into Git, the YAML file that's created.
Just to be clear, the Google Docs document is part of your pipeline. It's an artifact that's.
It's like an input to the pipeline. So the thing that's actually in Git is the YAML file that we generate from the Google Docs.
Nice.
And so the kind of ideas started out with what the client wants to write a Google Docs for what's going to happen. Could the production system just read that and do stuff with it? And we were like, well, no, not really, because then it'd be just deploying stuff that's not tested, and then I couldn't go on podcasts and talk about things anymore, that people might find out. So we thought, well, what if we could read the Google Docs, turn it into the config, and then test that config as part of the pipeline. And then if it passes the tests, then it gets deployed. And if they put some invalid stuff into the spreadsheet, it'll just catch that, and we'll see a failed test and won't have broken anything. So that stuff's been helpful. Lots of alerting is super helpful stuff. And oh yeah, last point on my list is I like to say if a deployment process frequently gives errors when it's run on customer-facing environments, then those are test environments, even if they're called production.
Exactly. Yep, that's right. That's exactly right.
I like that.
So fantastic list. Are you sure that's all that you have, Pete?
I've got to the end of my Evernote page now, actually. Yeah.
Wow. That's fantastic. Very, very good information. I appreciate all that. Anders, what are your thoughts on this? And then I have a follow-on question for everybody. You can start thinking about it, either around the transformation of waterfall to DevOps when you're working with big data, and the natural tendency of things like big data, because you can't just say to yourself, all right, I have all the data now. Now I'm going to do my work. So it forces you to sort of be agile. And so that's another a topic for us to talk after Anders comments on patterns for DevOps and big data. Anders, lay it out for us.
I think one of the kind of interesting patterns that, and this is maybe a little bit more abstract than most of the patterns we talked about before, which were practical and useful. This one is probably more useful than practical, but I was talking to a friend of mine who works at Google, and they do obviously a lot of big data stuff, but he's working a lot in the life sciences part, and they're working a lot with their kind of partners, pharma companies, and whatnot. And one of the interesting things they discovered with working with one of their partners was that there's a lot of bias in the questions that people ask. confirmation bias and hypothesis bias and those kinds of things. And one of the things that they started noticing when they ran a lot of machine learning algorithms on the data looking for correlations was that the correlations that the humans picked out of the data were weaker than some of the correlations that the machine learning was able to kind of figure out. And more importantly, and a little bit scary, was a lot of times the correlations that the machine learning found was correlations between like what machine was used to process the data, the DNA, let's say, or which person, which lab person did the processing, right? So there are certain people who, they do it wrong every time. Or there are certain machines that like, this one's not calibrated right, and so it's producing skewed data. And so they found a lot of just basic kind of problematic issues with the data that humans weren't looking for. The human scientist was looking for whatever was going to prove his hypothesis or support his hypothesis. And the machine learning was looking at it and saying, whenever Bob uses the machine in row number 3, he always screws it up and we get really wacky data. That's a problem, right? So we start to figure out, more interesting ways to kind of cleanse the data or notice the correlations that are that we won't look for as humans. So I think a lot of the interesting stuff that comes out of this eventually will just be, the kind of better data that we'll get as we start to figure out all the crap that's coming in the front end and how to, get rid of that or clean it up or ignore the stuff that's
that noise into actual signal.
Yeah.
Where you think, well, it's just, but it is telling you something if you have enough time and bandwidth to be able to see all the data. And that's the thing, is that human beings are really good at noticing differences. Right? That's what, for millions of years, that's what our eyes are sort of tuned to be able to see that. But we can't do it on such a big set of data because it's just overwhelming. So that's very interesting. So does anybody have any thoughts? Thank you, Anders. Anybody have any thoughts on sort of that transformation from or into a DevOps cadence if you're doing big data and how that process might work, or on sort of the natural proclivity of having DevOps type things be handled with DevOps because of the iterative nature? And Andy, you talked about that earlier. I don't know if you guys, anybody have any comments on that? Thoughts? No. Okay.
No, I think the crux, the one thing we always talk about is cycle time. When we talk about DevOps is, what's your lead time, what's your cycle time, where are you spending your time? And I think, the way that a lot of organizations today fall down on DevOps is, manual processes, manual testing, let's say, or rework, due to problems and those kinds of things. And I think, in big data, you'll never finish if you don't get a little bit more efficient in your cycle times and lead times, because if you have to go reprocess the data, or if you have to go, re-ingest the data, as JD was talking about, insert large delay here.
Right.
So I think you really do have to, in some ways, and in some ways it might lead you astray too, right? Because you might think that, we have to consider upfront all the questions we might ever ask so that we structure the data correctly, right? But you don't want to fall into that trap either, right? Because you do want to, be able to iterate quickly and understand that you don't know all the things up front and, all the good things that we figured out over the years with waterfall versus agile, which, kind of corners with DevOps quite a bit. So I think it's, the lesson is probably learned much more, it's a hard lesson to learn with big data because it's so expensive when you screw up and have to kind of start over. So I would imagine that if you're going to be a successful company or organization around a chunk of big data, you better learn that lesson pretty quickly, or you're not going to be around for very long.
Yep. And everybody.
And just on,
go ahead, Ed.
Sorry, Sam. Just one thing on that. I think it's also important to think about when you're moving from waterfall to one of the big things I find in DevOps is that sharing culture. Sharing ideas, sharing plans, sharing data, and this is, I think, very, very beneficial. When you move into waterfall mode, you might be inclined to just have you or maybe your small team doing the analytics on that data set, even a huge data set. But I think, especially when it comes to big data, that trope of sharing becomes a really strong forcing function. When you start to share data, people start to look at that data in different ways with different lenses. I think you get a lot more out of it. But you also start to talk the same language, and that comes back to that ideas of collaboration around data. So as you share big data and big data sets between, not just between individuals, but between teams. And you think of, for example, I mentioned turbines before as just one example. And I know we're working on a bunch of stuff around electrical power generation, grid type of stuff. And when you look at turbine data, engineering will have a whole different lens on that data from, say, facilities who are paying for the power to run that turbine, as opposed to someone like, for example, sales or marketing, who are selling the power that turbine generates. So they're looking for different things. So certainly when you move from waterfall, it might have been a case that you get the data set first, and then I get it after you. And then when I'm done, I give it to someone else to look at. But having all those three parties sharing ideas around that same data set means that as business leaders, and also obviously involving the dev and ops teams, you can work together to find what's important to each stakeholder. And I think that's a really important change from the way we look at waterfall to the way we look at DevOps and Agile, sharing data, creating shared insights to actually help drive that level of collaboration on a business perspective.
Yeah, more alignment. I love that whole concept of like, yeah, I never really realized that this was important to you. How is that important to our business? And how can I leverage what's important to you as something maybe it's important to me, maybe it's not. But yeah, knowing what's important to somebody is always a good thing.
Yeah, and that's certainly something we see it all the time. This idea of using the same data for different purposes. Just straight up data from systems, right? Using it to understand performance, but that'll also give you insights into security. There are things like that even within IT and development that you can share those large data sets to try and get common understanding and talk about things in the same way.
Right. Yep.
Yeah. Just jumping on that bandwagon comes back a little bit to something I mentioned earlier. A lot of the times we do look at the things like an automated deployment as an example. They're very concrete, discrete building blocks, but it really does come back to that cultural side of information sharing and, not to sound like I'm too flowery, but, as you say, empathy for what other people are doing actually helps us enjoy our work better and ensure a high quality outcome. I've worked with people who sort of do the whole like, oh yeah, I know my software is a bit iffy, but I'll throw it over the wall to QA and wait for it to come back because that'll take a week, and it's like, that's the wrong mentality, the wrong behavior. And it's the way I sometimes, I'm still, there's probably a good reason for it. I'm still a little bit iffy when I hear that there's a DevOps team, because I kind of think of it as being more like a Venn diagram of understanding different sort of capabilities within the business. The developers having a better understanding of what operations needs, operations understanding a bit more of what the developers do, testing teams and all of that. There's a high overlap in there. And I guess at a certain size, having a dedicated team for that is important. But I see it as more of a cultural push out across all the teams involved in the delivery of software to achieve a better outcome for all.
Yeah, there's nothing like adding another silo to your organization. You've got a dev team, an ops team, and a DevOps team.
Yeah.
They do the DevOps so we don't have to.
Exactly. Outsource that.
I'll throw it over to DevOps, and DevOps will throw it over to QA, and now I've got 2 weeks to wait for the outcome.
Right on. All right. Well, guys, this has been a fantastic conversation about big data and DevOps. Thanks, everybody, for joining. And we'll see you in a couple weeks on another episode of Continuous Discussions. Thanks, everybody.